Here we deal with a problem from JEST 2022. We are given an infinite potential well of the form v of x is equal to 4v naught x times 1 minus x for all x in between 0 and 1, and v of x is infinity otherwise. If the particle has energy, so a particle is confined in this potential well, and if the particle has energy E greater than or equal to V naught, which of the following could be the form of its wave function? So let us try to plot this potential. V of x at x equal to 0 is equal to, when we put x equal to 0, we have 4v naught times 0 times 1 minus 0, which is nothing but equal to 0. Now when x equal to 1, v of x is 4 times v naught times 1 times 1 minus 1, which is also 0. Now when x is equal to 1 by 2, we have v of x is equal to 4 times v naught times 1 by 2 times 1 minus 1 by 2, which is v naught. So if we plot v, then we will get something like this. At x equal to 0, we have v is equal to 0, and at x equal to 1 also we have v is equal to 0, and at x equal to 1 by 2, we have v is equal to v naught. So this is how our potential looks like. Now we are given that E is greater than or equal to v naught. It is given here, and we are asked what is the form of the wave function. Now when E is greater than v of x, we have momentum P is equal to root of 2m times kinetic energy, which is E minus v of x, total energy minus potential energy. This is equal to, one thing I forgot to mention, when x is not in between x equal to 0 and x equal to 1, we have v is equal to infinity. So here and here we have v is equal to infinity. So this is an infinite potential well. So P is equal to root of 2m into E minus v of x. Now P is h by lambda. This is equal to root of 2m times E minus v of x. Now when v of x is small, when v is small, E minus v is large. This implies lambda is short, lambda is small. And when v is large, E minus v is small. This implies lambda is large, lambda is long. You can see in this figure that v is small near x equal to 0 and x equal to 1. Therefore near x equal to 0 or x equal to 1, E minus v is large. This is because v is small. V is small near x equal to 0 or x equal to 1, and this implies lambda is short. And at the center, at x equal to 1 by 2, v is at the maximum, v is peaking, v has a peak, v is at peak. This implies E minus v will be small, E minus v will be smallest, which implies lambda is longest. Now, lambda small means rapid oscillations, and lambda large means, lambda is long means slow oscillations. Therefore, we expect rapid oscillations near x equal to 0 and x equal to 1. So here in the option A we have rapid oscillations near x equal to 0 and x equal to 1, and slow oscillations at the center. So option A is the correct answer here. Near x equal to 0 and x equal to 1 we have smaller wavelength, and therefore we expect the oscillations to be rapid. And near x equal to 1 by 2, v is peaking, E minus v is small, which means lambda is longest, and therefore oscillations should be slower. Therefore the correct option here is option A.